So what we are doing now is we're working with some different identities that you have not seen before. They're called sum and difference identities. And if you've taken the notes out of the book like I asked you to, you would have seen there were 6 different identities that we are going to be using. Okay? The reason these tend to show up, okay, is because what you're able to do, sometimes there are nice trig identities that show up when you're solving equations or when you're proving identities like we've done in the past, okay? And knowing these identities can help you simplify or help you verify complicated trig identities, okay? It takes a little bit of time to get to know these, but once you know them, they're actually pretty simple, okay? The common mistake is, okay, is if somebody sees this, okay, the sine of 30 plus 45. Okay. Some people think, well, just use the distributive property. Do the sine of 30 plus the sine of 45, and that definitely does not work. Okay. By order of operation, or PEMDAS, we know that we need to do what's in the parentheses first, so 30 plus 45 degrees would be 75 degrees. And then our 75 degrees is not one we just know off the top of our head, right? 75 was not on our time test or anything like that. Okay. So you'd have to actually type in your calculator the sine of 75 degrees and get an answer. All right. Well, that answer is going to be a decimal. That decimal is rounded. It's not exact. I'm going to teach you how you can get an exact answer using the values that we do already know. Okay. So that's kind of where we're going with this. All right. So from your textbooks, the sine of a plus b was equal to what? See how good my memory is from last year. Sine A cosine B plus
cosine
A sine B. All right?
Yep.
And then the sine of A minus B was exactly the same, except it has a minus in it. The book wrote both identities all in one. Okay? So I'm just writing them out separately here for you. So those are your sine identities. There's a proof for this. I don't know that you care about the proof as to why these identities work. If there's time, I definitely could put that on there. In fact, maybe I'll put that with, or I'll add a video of that since I got to do a video anyway of the next set. Okay. So the proof is not easy enough to where I can just come up with the proof and that helps me determine the identities. The proof itself is a little more complicated, so to me it's almost easier just to memorize them. My opinion. But I can do the proof if you would like on that video. Okay. But so anyway, those are your identities for the sine of an angle plus another angle, or the sine of an angle minus an angle. Right? So, if you don't mind turning just a little bit.
I'll get started there.
Okay. If you wanted to find the sine of 75 degrees, if I told you to find the sine of 75 degrees, that was the thing I asked you to do. And I said, I want the exact answer. Okay, the exact answer. I don't want the decimal answer that your calculator would give you. Would you agree that doing this is the same thing as doing what I have written here?
Sure.
Because 30 plus 45 is 75, right? Why did I choose 30 and 45? Well, aren't those angles that we already know? We know the 30s, we know the 45s, we know the 60s. Sure, 60 plus 15 would give me 75 as well, but do you know 15-degree sines and cosines? No, so don't use 60 and 15. Yeah, you know 60, but you don't know 15. Use angles that you definitely know. Okay, so now, this is like my A, this is like my B here.
So it will always add up to like sines or angles that we know.
You'll be able to use angles that you know to come up with them. Yep. I won't give you like, find the sine of 73. You know, yeah, you're not going to have to do that. Okay.
Maybe for your test.
So, here, I'm just going to follow this identity. This says if I have the sine of an angle plus another angle, all I got to do is the sine of the first angle, so the sine of 30 degrees, times the cosine of the second angle, so times the cosine of 45 degrees, plus the cosine of the first angle, so cosine of 30 degrees, times the sine of the second angle, so the sine of 45 degrees. Everybody see how I used this identity except instead of with A's and B's, I'm using 30 and 45. You guys follow me there? Now we just do the math. What's the sine of 30?
1/2.
You guys got it quick. Cosine 45?
Root 2.
2.
Cosine 30?
Root 2.
Sine 45. Okay. A little help with some fractions here. 1 times root 2 is root 2. 2 times 2 is 4. So you got root 2 over 4. Root 3 times root 2. Can you multiply the 3 and the 2 together? Yes, because they're both underneath the square root. So root 3 times root 2 is root 6
Over 4.
over 4. They nicely have a common denominator, so I can write my answer as a single fraction. The square root of 2 plus the square root of 6 all over 4. And no, the square root of 2 plus the square root of 6 is not
Square root 8.
the square root of 8. Doesn't work that way.
Why
Okay?
not?
What's that?
Why not?
Because these are really exponents. I have 2 to the 1/2 power plus 6 to the 1/2 power. And for instance, if I would have, let me just use nice 2 to the 3rd plus 2 to the 2nd. You can't, well, I'll even use the same thing, all right? That would not be 4 to the 3rd or anything like that, because you'd have to do this, get that answer first. You'd have to do the exponent before you could add. So you definitely can't add the bases together because both of them are being raised to a power first. So that would be kind of logical.
My calculator just gave me that.
Yeah, lucky you.
So
You're going to have to show me your work. You're going to have to show me your work, but you are able to at least know what the answer is. Yep. Okay?
Lucky.
So,
Your man use that calculator.
all right. Do it for a price at least.
Yeah.
Fantasy football trade or something.
Yeah. Time really.
Okay? So there's kind of an example of using this first identity right here. All right? Cosine A, cosine of A plus B. Here's your identities for that. Cosine A, cosine B, minus sine A, sine B. This one's exactly the same, but there's a plus sign. And again, we'd use them very similar.
Oh, you messed that up.
Nope, I'm gonna, tell me how I do, let me try. Right or wrong?
That's right.
Good. Okay, memory's still somewhat okay. Okay? So here are all your sum and difference identities.
Is the number 3, is that supposed to be plus on the right side?
No,
Here?
that's right.
No.
It's supposed to be negative.
Nope. Alright, so, memorizing them.
Should we have done your homework?
You'll notice that if you have one of the signs memorized, the other one's exactly the same except you switch the plus to a minus, right? Same thing on the cosines, they're identical except it switches. Same thing on the tangents, they're identical except again the signs change, right? So really there's not 6 to memorize, there's 3. Okay, if you can memorize each one individually, then the other one, the minus versus the plus, is the same except change your signs. Okay? So really you just kind of have to memorize 3. The sines and cosines tend to get people a little bit confused. Okay? My crazy way that's always gone through my head is on the signs stay the same. On the signs stay the same. So if I have a plus here, I'm going to have a plus here. If I have a minus here, I'm going to have a minus here. So on the signs stay the same. On the cosines stick together. I think cooperate, stay together, something like that. So the cosines are together. It helps remind me that the cosines are together on the cosine ones were not the case on the sines one. I don't know why. That's just my way of distinguishing between the two of them. Okay, if you guys have some better ways to do it, come and let the class know, that'd be great. Okay, so that kind of helps me between those two, and then I just kind of have to memorize tangents the way it is. So, you'll definitely get some problems that'll be a lot like this. Let's do another one maybe. Let's do cosine of 165. How might we do the cosine of 165?
120 and
I
45.
got it. Where are you
Okay. What'd you say?
120 and 45.
120 and 45? That would work. Anybody have something different? What'd you have? 30 and 135? Would that work? Do you know both 30 and 135? Good. Okay. 210 minus 45? Would that work? Those are ones that you know, 210 minus 45. So, a lot of different ways to do it, right? There's not just one way to get your answer. I heard Derek's first. You said cosine of what, Derek?
120 plus 45.
Okay. If you want to use your 135 and 30, Bailey, and just watch how it still works out to the same answer, you are definitely welcome to, or if anybody else wants to. Okay? It really doesn't matter. Here's my only piece of advice. If you're ever having to do tangents, try to avoid tangents of 30. Why?
Because square root of 3.
Root 3 over 3 is not very nice. Tangent of 60 is simply root 3. You don't have to deal with a fraction then. So if it ever possible, I try to avoid tangents of 30s just because I don't want to work with that radical fraction. Okay? So let's follow the rule. I got the cosine of A plus B, right? So what am I going to write?
Cosine A times
But you go ahead and use the angles that are in here. Yep.
Cosine 120.
Cosine 120,
Cosine 45.
cosine 45,
Minus
minus
sine.
sine 120,
Sine.
sine 45. Cosine 120,
one half.
cosine
60.
1 half,
Cosine of 60.
negative 1 half,
Yeah, negative.
negative 1 half. Cosine 45,
Negative 2.
just 45,
Root 2 over 2.
root 2 over 2. Minus sine 120,
Root 3 over 2.
root 3 over 2, sine 45.
2.
2.
This is going to be difficult.
2 or 4?
Positive or negative?
Negative.
Negative root 2 over 4 minus
Root 6
root 6 over 4
equals negative root 8 over 4.
What?
No, sorry.
You just talked about that, Derek.
I'm science guy.
Went over this.
that was awesome. Negative root 2 minus root 6 all over 4. Could I write this? Is this the same as this? It is. If you put the negative out in front of a fraction, you're basically making the whole entire top negative or the whole entire bottom negative, one or the other. Okay, so I know most of you are going to put this, and that's totally fine. Okay? But, yep, so very good there.
I saw a picture on the sidelines.
Alright, so you'll have a lot of questions, potentially like this. You'll also have some identities. Okay? I think you'll also have some identities in there. Can't quite remember the assignment off the top of my head, but I'll have to look here in a second. If I ask you for the cosine of 13 pi over 12, if I would ask you to find this, guys, listen real quick. Cosine of 13 pi over 12. Here's my advice. Change it to degrees. Most of you are not going to know what fractions add up to make 13 pi over 12. Okay? Except for Caleb, of course. Yeah.
A baby face.
All right. Change that to degrees. I think it's 205. Okay. I think it's 205. But you aren't going to know that it takes, 2 pi over 3. And I don't even know. I can't do it. You're better than I am.
Yeah.
So, change them to degrees and do it in degrees.
195.
Okay? Oh, it's 195. So, yeah. I don't
Derek's too cool for you. Derek's varsity math.